Okay, so hello everyone. This is the tutorial to a BERT-based starter kit for the IndoML DataThon that I hope you all are taking part in. So I will be going through the collab code as well as parts through my code that I have. This is the whole repository. I'll put this link in the. You can find this link in the description, and I will be going through my code as well. But I have prepared a collab demo so that all of you can run this. So while that is opening up. Just keep this aside. Okay. So first things I think like you can also read through the tutorial, but so the basic thing is that this code, my repository is supposed to work on multiple GPUs or multiple machines. If anyone wants to scale this up, you are like this code is completely DDP, so it works, and it also works on the Collab GPU. So yeah, and then so yeah, you definitely feel free to play around with the repository because I have put at several places I have added stuff like you can change this, you can change that, and yeah, that would be ideal for you too if you just want to use this code. And okay, so we'll go through this pre-processing dataset as in the torch dataset, and then so I'm using a BERT model, and I will also describe the actual thing that I'm doing so along the way, but yeah. So okay, so I'll just clone the repository. You can just run this. If you want to save this collab, you just have to save a copy in drive. If you hit Command S or Control S, they will prompt you. You can save a copy in drive and then modify this according to if you want to modify it in any way, basically. So now, before by the time this gets unzipped, we can also download the data, right? Um, so basically, this is the Codalab page for the competition, and you can download the files from here, right? So yeah, I think this takes only a few minutes, and even this takes, and then once you have the data, you can just use this. I mean, like you can just run the whole thing as is, and yeah. But the uploading, like the data upload actually takes some time, so I would advise if you could create a drive and then mount it, that would be much faster than actually doing this, basically. So yeah, I think I have the data already, so I'm just going to upload it. Yeah. Also, guys, so like don't change the name after you upload it. Like it, this is supposed to work as is, so it will just go through. So you don't need to change anything, like rename or anything like that. And then while that is while it's being uploaded, um, I have trained this. I have trained this model on a proper the whole trained dataset, and this is the best score I was able to get with very default parameters. So you are obviously free to vary that and do whatever you want to do, crazy stuff with the model. So and also there will be like a big error at the end of this. Like just ignore that, it's fine. This all of this is just fine. This is going to happen because there are some dependency conflicts with how Colab expects its packages to be and how I am managing my packages. So yeah, so ideally once this code cell is run, you should have a data folder here, right? Because this has all the data, and yeah, then you can just, so we will cd into the folder, and then I will go through this pre-processing code, and so yeah, but this is how it will. So this is just pre-processing, as in it will create a different folder it will create different files inside this data directory, which are all JSONs and processed in a specific way that I am using. You can also pre-process it in any other way that you didn't fit, but and this also prints out the unique number of unique categories, and yes, so it should be data. So this is these are the files that should be generated once you run this, and this is the maps. So basically maps is just suppose you have 5066 unique values. So L0, so details brand to IDX would just map each of these unique values to a unique integer basically. So just to train the model, you need an integer output. So that's what this is doing. um, I'll go through the pre-processing code now, which is um, also guys, if you face any problems like running this code or whatever, like it's not functioning as is, please feel free to raise a PR or an issue or something. So this preprocess function is basically, it just expects this data directory in case you like you modify the code and you have your data, you have multiple versions of the data, so you can specify this. And this fname is basically the file name that you want to process in that directory. So for us it could be like this attribute test.data or something like that, right? Yeah. So so basically I just like I figure out if there's a solution or not, and then so I'm pre-processing this file, as in I will go through each file and then I just strip the opening and closing curly braces, and then I match basically keys to integer value or keys to a string value, and then this is just storing the thing in a dictionary. And once I have it stored, I'll just dump it as a JSON file. Right now, this is a JSON lines object, so you can also do it differently. But this is just what I was doing. I just considered it as a plain string, and that's how I was doing it. And this categorize function is, as I said, it just maps each integer. So basically, I create a set, and then I keep adding stuff to that set, like unique values. And at the end, I will have the set will basically be all the unique values only. And then I just enumerate it to get this index, and then and then I also store this reverse, because at the end you want to predict using the test data set, so you need the reverse mapping as well. So you do that, and then so this is the code you want to run. If you're outside Colab, if you're running this locally, you might just want to call python 3 preprocess.py, given that you've stored your data in the data folder, right? So that's the preprocessing function. Then these are the data sets, and as I'm saying, like, do not use trim equal to true when you're training your own models, because this trim will just reduce the data set massively, and it's just to show you that the code is working basically here. So don't use it when you're doing it. I'll go through the data set code as well. So this reviews data set is just what I have named it. You can name it differently, you can do whatever with it. So it again expects this data directory, it expects the split, and it also expects the output. So output is basically, so I am training a BERT model, and I will go into details later, but this BERT model is going to be different for all 6 cases basically. So because there are 6 columns in the input, so output, L0 category, brand details, brand, L1 category. So I'm just training 6 different models for all the 6 labels. You can definitely play around with this. I think the generation based pipeline that the previous video was addressing, the previous tutorial, it was definitely addressing everything at once. So that is something I'll again go into details. But so with this load data, what I'm doing is basically inside the load data, I open that JSON file that I created, and then I like, I think you can just go through this code, but either way, it just loads the data frame object basically. And because I need to work with, like, I think it's much easier to work with pandas data frames, so I just create a data frame object basically. So like this one has details, brand, L0, L1, all that in this data frame basically, and that's the thing. So if you have the output, you have it. Otherwise, so basically, if you can see, I'm loading both the solution as well as the normal file, and what I'm doing is I'm processing like the keys in there. So like for the test case, it won't exist, right? For the test case, it won't exist, and so I just load this empty dictionary, right? And so I add this empty dictionary just so that this is easy to do, right? Yeah. So yeah, basically, and then I load all the files, like the manufacturer details on all the attributes along with the solution. So like it's a unified data frame of everything. And then this load map function is just a utility. It just loads the required map that I just showed. Like the maps are stored here. So these maps I'm just loading. So suppose I'm working with L0 category, I just load both of the maps, like L0 category to index and index to L0 category, both of them, right? So these are the two functions. This is the usual. So this get item returns a dictionary, which is I think um, yeah, that's just what I have chosen. Again, you can change this, but this won't really affect your performance in any way. So this is the thing I have chosen. And if you notice, like it's the test split, you obviously don't have the output, so I can't return the output. And that's it. This is the length function. Then yeah, so what I'm doing is I load these, and then so if you go through the data set, some of them do have NA, like, so these values are not available. So if that's the case, we don't want the model to predict not available, so I need to remove not available from here. And then yeah, when I remove not available, and then I also need to remove it from the keys basically. So yeah, that's there. And then once I've removed it from the keys, I can just map the whole output to this integer basically, right? And so if you can go through this, you can change this. I'm not going to go through the details here, but so this is actually what you should read and go through. This is the part where you can actually change and get a slight increase in performance or something like that. And then yeah, this is the trimming part, which I definitely don't recommend you to do, because trimming will just reduce your dataset to 1000. Or you can change this, but yes, I think if you can work with the whole dataset, work with the whole dataset. And yeah, otherwise this can also help you debug basically. And then yeah, this just verbose information. So that's the thing. And okay, then I will go through this data loader function as well. So basically this data loader is the normal torch data loader, but what happens is I need to specify my own collect function. So you can specify everything else but the collect function, so that's why I created this utility class, right? And it doesn't allow you to pass a collect function, right? Yeah, and I assign the collect function myself. So this collect function is also very simple. As I said, I am getting a dictionary, so I need to write my own collect function. So what I do is this: I just map it to example of input, and then yeah, I'm just checking if it's not test, because if it's not test, I need to convert the labels to this long tensor, and otherwise I just keep it as a -1, and then these are the IDs basically, right? Yeah, and so this is the data set, this is the data loader. Again, this is like a dummy run, you can see that, but I'm already doing that here. So this is the dummy run. So this is one of the things: input product name uniball x2 whatever sold at. This is what I was asking you to go through. Please go through this part specifically where I am creating the data set. I think here, if you can go through this would really help you. And so that's the data set. And then I think we move on to these models. So again, so these are very simple. These are BERT small models. You can also try out a bigger model, right? Yeah, this is the basic one, BERT based uncased, and like there are bigger models than this as well. You can try them, but remember to like save these in some particular places. Like I am using this, and if you don't use this, like change this to whatever. Like you need to change some code to just make it function basically. That's the only thing. And um yeah, so again I will go through the task myself. So the task is basically some like a sentence along with the all the details that you have, like the title, manufacturer details, goes into the BERT model, and the BERT model outputs the embedding, and using the embedding of the CLS token, I perform classification across those. I just have a linear layer on top of it, which I will again like when I'm training it basically. Yeah, the next part, when I'm training it, I will go through like how basically the actual model is working, because that the BERT is just one part of it. And so this is all distributed data parallel. If you want to go through that, please go through that. But like again, this all of this is just DDP stuff. So I'm just creating the data loaders and data sets. And but I really want to go through the model, because so I have the tokenizer, I have a LM language model, right? I set it to eval mode. And the other thing is, like, I define this head, which goes from lm.config.hidden size, which is the hidden size of the BERT model, to this length of train output idx basically. So you want to do a classification between all the unique values, right? So that's what this is doing. and so I just output one thing, and then so basically you can put a softmax and or do pick the rmax or whatever. So that's the whole model basically. And so I trained 6 different heads for 6 different tasks. That's the basic architecture. Sorry for that. um, I would also suggest that you play around with this, or I'm also freezing the BERT model, which is here. I think this was working fine for me, but again, this is up to you. I think it might be better if you use some other type of BERT model, right? Yeah, mine is very simple. You can read through this. I think this is, I guess, also important. So um, I have provided this trainer file that you can just run, and right now this is just going to train. This will not do a test, and this will not be a valid submission basically that you can just put on CodaLab. If you want to do that, you can just uncomment these lines and actually have a file that can be submitted to CodaLab. But mind that this takes a very long time, about 49 minutes for, like, because I have a very small batch size as well. So you can increase that and maybe you can decrease the time, but it takes a lot of time. So I am not going to do the test run, but I will show you that the training is working as expected basically. And so this was just the data loading, and then yeah, so you can see that you can also see the GPU utilization will go up. Yeah, I think if you observe for a longer time, it will go up even further to some, like, yeah, definitely. So what I would suggest is like pick some batch size that fills out the entire GPU RAM. Instead of me, I just have a batch size of 2. So yeah, that's the thing. And I will go through the trainer code while that thing is running. So again, I'm using this Atom optimizer. You can again change this. I'm using the cross entropy loss, which you probably you can add some regularization or something if you want to. These are all like very basic potential directions, but definitely if you go through the code, you will learn a lot more. And this will automatically make this outputs directory, and so this outputs directory will basically um, uh, like, it's necessary to store all the, when I'm doing the testing, I will store the um, like the predictions in this outputs, right? Because again, the task is based on item accuracy. Item accuracy is when the model gets everything correct, and so to check if the model got everything correct, you need the predictions for a particular object on all 6 labels, right? So to do that, I need to store the test predictions on all 6 in some file and in some folder, and so that's what I'm doing. I'm storing all of them in outputs. So okay. I think this code is like the standard torch pipeline. So this is like a train step. You tokenize the input, send the input to the device, also the output to the device. Then do a forward pass through the language model. You pick the class token, you pass it through the head, and the output will then be passed with it targets to get the loss basically. And then you do this. This is the simple. It's the basic torch pipeline. Then this is the eval step. You do everything similar up till here, but then so what happens is like, I am also reporting the loss on the validation set, so that's why I'm doing this. Otherwise the outputs is just going to be the argmax along dimension 1, right? So you can get both of them. And so this final test is basically um, when it's the final, when I'm running the test thing, I don't really want to evaluate, right? I mean, like, I don't care about the loss then, because I don't have the outputs as well. So that's the thing. And this training function is just going through each of them, like, see, like this will just iterate over epochs. And I'm storing the best model according to the F1 score. I think it's also mentioned in the um, notebook, right? You would like to change this if you want to, like, maybe some combined metric or something like that. Then yeah, I log every, you can also change this. I log every 10,000 iterations or so. Then yeah, this is all DDP stuff. I think if you want to go through it, it's fine, but otherwise this works. I've tested it on multiple GPUs. And okay, yeah, so if this is like, I'm just loading the best model. So basically after the end of the uh, whole training, I'm loading the current, like, the model inside my object. This trainer is an object, right? So this self.lm, it becomes the best model basically, right? So I'm just loading that, and then this is the test function. right? So this test function again sets this to eval mode, and then what happens is like as I said, I need to store the outputs. So what I'm doing is I get the outputs, and then according to IDs, I need to sort them as well. So I according to the IDs, um, I'm just storing the outputs basically for each of them. And if you see, I'm doing the reverse mapping. So my model will output a number, and I need to convert that to some text basically. So this is the test function, and yeah, I don't think anything else. Again, like feel free to go through this DDP code, but again, I know I have checked that it's working. So yeah. Mm. So that's the trainer function. I think this training will take some time, like because I'm running for 5 epochs on each thing. So I think it's taking 34 seconds per epoch, and then 5 epochs. So yeah, that's going to take some time. But yeah, you can check back when this I the model I the notebook I have uploaded already has these outputs, so you can read them. But I'll just go through the evaluation on how that code is working, and then you can also change that, I think, if you want to. But um, so basically, if you want a valid submission, what you have to do is you need to uncomment these lines, which will take some time to run on a single GPU. But once you have that, what will happen is there will be outputs folder with all the outputs, and then you can just run this post process from evaluate, and that will like create a unified zip file that you can just submit to the Coda lab basically. So these are all wrapper functions because we consider these macro like all these specific parameters around sklearn. So these are just wrapper functions. And then for post process, what happens is like this just combines all the data, sorts the IndoML IDs, and see, this is where it's sorting the IndoML IDs, and it also maintains this order. This order is really important. Like you can't really have L4 category before L3 and like in your submission file. So that's important. And then this will zip and create a zipped file basically. So the input will be like, yeah, definitely I think you should change this. Change the name as this is just attribute test BERT baseline dot predict. You can change this to whatever your name is. I think you can, if you read this, it's also written that you can just name it like what your name is, like attribute test underscore your name dot predict. But it must be, so this must be maintained. You can't change this, and you can then also rename this default submission or anything, right? So this is the whole code. I don't think I've left anything. um, yeah, feel free to I am running this on Colab, so you can check the Python version as well. But yeah, this will take some time to run. But if you, as you can see, I think it's the model is training. So if you see this one, 0.8, 0.14, 0.19. But as I said, the best I was able to achieve with this naive model is just 30% or something. So yeah, definitely, I think you will have to fiddle around with parameters a lot. 30%. But it's interesting to note that this is 94.6 here on details brand, and it's the model is really good on individual tasks, but when it comes to item accuracy, it sucks. So I think that's something to note, and you need to work around that. And yeah, thank you. Please raise any questions or anything on the, you can raise a issue, you can raise a pull request if you have something to add. And I will also add this YouTube link here, so you can just yeah. Thank you guys. And if you have any questions, we have another Ask Me Anything session soon. So yeah, you can also drop by there. I think I'll also add the Discord links and everything in the description, so please feel free to join them. Thank you.